Welcome to Sustainable Energy Hawaii's discussion, Renewable Energy and Sustainable Systems. Since sustainable is in our name, we felt it was important that we clearly define what that word really means, especially since it's become one of those cliches tossed around like green or clean or carbon neutral. The word sustainable has a very specific meaning. When something is sustainable, it exists as a vital, functional part of human activity so that its societies are able to meet their needs while preserving biodiversity and natural ecosystems for future generations. In other words, we consciously act today while considering how that act will impact everything that surrounds us in the future. That's how we behave when we know we're a part of nature and not apart from it. With the effects of climate change impacting communities around the world, we now know how important it is that we change our overall modus operandi, or the way we do business, if you will. Probably the most significant way we're attempting to mitigate our contribution to an increasingly hostile climate can be seen in the effort to end our use of carbon-based fossil fuels. The challenge has been how to do that quickly and keep our economy functioning. Energy consumption equals GDP. To that end, we've been told that getting our energy from renewables, like solar and wind with battery backup, or driving EVs, will make the big gains we need to win the war on climate change. This is all well and good, but since few things are really as seen on TV, I'd like to use this time to consider whether or not these renewable energy systems are actually sustainable energy systems. That's because most people don't realize that renewable energy does not mean the systems used to turn that energy into something usable are also renewable. We think it's important to understand the distinction between the source of energy and the systems we use to access that energy. For example, to what degree does our future planning factor in what these high-demand, renewable energy systems will likely cost to maintain over their 15 to 25-year life cycles? To what degree do we consider that the entire planet will be looking to replace its renewable energy infrastructure in only 25 to 30 years? Do we factor in whether the natural resources we're consuming at astounding rates will still be available in the same quantities or prices? For example, we're already hearing about supply chain issues, causing delays in system delivery and seeking higher costs. Just this year alone, polysilicon production, the core element used to make solar panels, will be 42% greater than it was in 2021. That growth in supply has still met with a 15% price increase over that same year. So even with double-digit growth, demand is still outpacing supply. At the same time, China, and the geopolitics that go along with it, produces more than 3/4 of the world's polysilicon and more than 80% of the finished PV panels. Now let's look upstream at the production supply chain and consider just how dependent that chain is on the liquid fossil fuels currently used to mine all the raw materials, transport all the manufactured parts and completed systems around the world. Simply put, all the energy used for industrial transportation and mining comes in the form of liquid fossil fuels. Today there is no substitute at scale. Period. If we accept that as fact, how then do we truly eliminate carbon emissions without making the replacement of those fuels a top-tier mission-critical priority? And then, what's going to replace them? Global consensus says that replacement will center around renewably produced hydrogen. Now, the trick is to do it using systems that are as sustainable as possible. This is where Hawaii can play a meaningful role. While Hawaii may be small in physical size, what it can contribute to the replacement of liquid fossil fuels is huge. Starting with Hawaii Island's abundant geothermal energy, there's also access to abundant untapped water resources. The Big Island has large areas of undeveloped, unoccupied land, and access to a workforce that will discover decades of demand for well-paying hydrogen-related jobs. From a business standpoint, Hawaii sits in a location that's economically advantageous and geopolitically important within the new global supply chain. As the shipping and aircraft industries decarbonize their powertrains, mid-Pacific refueling options will likely become desirable, since many will be using fuels with half the energy density of the fossil fuels they've been using for more than a century. All this bodes well for Hawaii's future. However, what we need is the social and political will to make this opportunity a reality. Sustainable Energy Hawaii envisions a robust, clean geothermal hydrogen production operation on Hawaii Island. We'd like to show you what this might look like, but first, I'd like to say that geothermal can, if regarded as a community resource, be the center of a broad economic revival, bringing increased financial stability for the community to which it really belongs. However, along with the social and political will needed, this would require a new type of business governance model, one that's owned and operated locally, and through its earnings furthers local self-sufficiency, resiliency, and social equity. Here's what this operation could look like. Currently named the Pacific Islands Green Hydrogen Hub, we see an opportunity for Hawaii to diversify its economy while decarbonizing our atmosphere at a much larger scale than with RPS 2045 alone. What will this hydrogen hub cost to build, and how big will it be? What you'll see is going to be a broad vision statement, one that of course has a lot of parts that are yet to be detailed. The head end of the production pipeline would be a newly constructed geothermal power plant. This would likely involve more than one generation site, none of which would be located in Puna's East Rift Zone. The plant would be purpose-built to provide power for both hydrogen and green ammonia production. We envision the capacity of the geothermal plant to yield between 250 and 500 megawatts at an early cost estimate of $625 million to $1 billion. We plan to exclusively use the output of the geothermal plant to power separate green hydrogen and green ammonia production plants. The goal is to position Hawaii as a reliable, industrial-scale refueling port where the carbon-free fuel of choice can serve trans-Pacific shipping, trans-Pacific air traffic, as well as provide carbon-free fuel for U.S. military operations in Hawaii. We anticipate local demand for these fuels to grow too, as heavy-duty vehicles such as buses and land-based freight transport services adopt the fuel cell vehicles of the future. Preliminary estimates find design and construction costs for this part of the operation to come in around the $375 to $450 million range. We plan to build a third production facility that will combine the hydrogen we produce with nitrogen from the atmosphere, producing green ammonia. Ammonia is a readily transportable form of hydrogen. It can serve in its raw form to provide power to the heavy-duty drivetrains in ocean freighters, heavy-duty mining trucks, and other industrial-sized vehicles. It can even serve as a replacement for jet fuel. At this time, we're still exploring options for producing green ammonia, leaving a range of facility costs yet to be determined. At this point, we can review a list of the target markets we expect to develop between now and the time our planned production pipeline is operational. We have trans-Pacific shipping, trans-Pacific airline refueling. We have Hawaiian-based transport operations for the U.S. Department of Defense, including the Navy, Air Force, and the Army. We expect the adoption of fuel cell grid storage, which has been shown to be a less expensive alternative to batteries. Again, we have heavy-duty vehicle fueling and, of course, ammonia for fertilizer. In pursuing this vision, we're making some economic assumptions, some of which I may have mentioned earlier, but I can run through them again. For starters, what we're talking about here is still a very nascent, emerging market, but one that's building global momentum quite rapidly. As I mentioned earlier, from one end of the planet to the other, governments and private investors are betting on green hydrogen to play a major role within our energy transition and serve as a liquid fossil fuels replacement used to power industrial-scale transportation. One factor that should influence this is found in the fact that 2/3 of all goods imported into the U.S. come from Asia. With that much traffic crossing the Pacific, refueling midway will likely become a necessary option for those ships using lower energy density, carbon-free fuels. Ammonia is also a leading carbon-free candidate to replace aviation fuel as heavy transport decarbonizes. Over time, the cost for hydrogen sourced using solar and wind systems will likely rise due to growing system demand, contracting natural resource supplies, all combined with mounting geopolitical pressures, especially with Russia and China. Geothermal and hydroelectric generation systems have much longer life cycles and are the only true baseload, firm power sources that produce carbon-free power. Time is of the essence to get this up and running. For many reasons, Hawaii needs a project like this to become operational. The world needs it too. In order to produce hydrogen and other hydrogen-based products competitively, we intend to operate as a private, independent power producer in an attempt to avoid as many of the customary regulatory hurdles that are encountered by public utilities. An essential component of a venture like this is to maximize benefits for our local community. This needs to be an integral part of the company's governance policy. Some of the benefits we expect an operation like this to produce include significantly diversifying the local economy, not just on Hawaii Island, but across the state. That diversification will grow job opportunities in skilled areas outside what have been traditionally available. These will be good-paying jobs in multiple related fields that have a future that should offer a long career and involve industry growth over time. This industry will bring dollars from outside the state and in significant quantities. Those dollars will flow through the economy, helping all businesses along the way. With this, we should see an overall rise in the community's standard of living. Producing hydrogen locally will mitigate our reliance on imported energy. It will also expedite our ability to decarbonize all sectors of transportation, as well as offering an opportunity to retrofit power plants that previously ran on oil products. All of these benefits will enable increased social equity, stability, and security. Another focus this operation must have is providing some level of financial support to our local farmers. They have to compete with foreign producers who operate at a scale that makes local production more than financially challenging. Lastly, it can offer our youth a reason to stay home. The job opportunities that can come with a project like this should make a real difference to the next generation. Here's a list of our leadership team and the collaborative advisors who have helped inspire what we aspire to achieve. We thank them all. We believe there's a need to make an overt, conscious decision about how we want to live in the future. Time is not on our side, so we should do it soon. Mahalo.